Light is something we see every day. But what actually is it? It feels real. It fills a room. It lets you see everything around you. But if you try to hold it, there's nothing there. Light has no mass, which means it isn't made of matter. You can't weigh it. You can't pick it up. And yet, it carries energy. It travels across space, and it allows you to see the entire world around you. So what is it? To understand that, we need to change how we think about what a thing is. Most things in your world are made of particles, atoms, molecules, solid objects, things that take up space and have weight. But light is different. Light is made of photons. Now, the word photon can be misleading. It sounds like a tiny object, like a grain or a particle you could hold. But it isn't like that at all. A photon is better understood as a packet of energy, not a solid object, not something with structure or mass, but the smallest possible unit of light itself. And this is where things start to feel strange, because light does not behave like normal objects. Light behaves both like a wave and like a particle at the same time. Imagine a ripple moving across water. The wave travels across the surface, but the water itself does not move across the lake. It simply moves up and down, passing the motion along. Light behaves in a similar way, except there is no water. There is no medium. The wave is the thing. A photon is like a single pulse of that wave, a small bundle of energy moving through space. And this doesn't just apply to visible light. Everything from radio waves to microwaves, to infrared, to ultraviolet, to X-rays are all made of photons. The only difference between them is energy. Low-energy photons form long, slow waves, like radio signals. High-energy photons form short, intense waves, like X-rays. And right in the middle is visible light, the small slice of the spectrum. So when you look around a room, you are not actually seeing objects directly. You are seeing photons bounce off objects and enter your eyes, carrying information about the world. That is what vision really is. It's energy being interpreted as reality. But there is something even stranger about this. Photons have no mass at all, and yet they still carry energy. They still have momentum. They can even exert pressure. In fact, sunlight itself very gently pushes on the earth all the time. So how can something with no mass still have energy? This is where physics starts to move away from everyday intuition. Photons always move at the speed of light, and their energy comes entirely from that motion. Now, to understand this more deeply, we need to go one level further. When we say light is a wave, we have to ask, what is actually waving? If there is no water, no air, no material, what is moving? The answer is something called the electromagnetic field. This is something that exists everywhere in space, even in a complete vacuum, even in total darkness. The electromagnetic field is always there. And when it changes, when it oscillates, that traveling change is what we call light. So a photon is not an object moving through space. It is a small packet of change in the electromagnetic field, moving through space and time. And this is why light does not need a medium. It doesn't travel through something. It is the motion of the field itself. This becomes easier to picture with an analogy. Imagine a stadium wave. People stand up and sit down, one after another. The wave moves around the stadium. But no single person moves around the stadium. They only move up and down. The motion travels, not the people. Light works in a similar way, except instead of people, it is changes in the electromagnetic field. And instead of a stadium, it is the entire universe. Now, this also explains why different types of light have different energies. Because the faster the field oscillates, the more energy the photon has. Faster oscillation means higher frequency. Higher frequency means more energy and shorter wavelength. Slower oscillation means lower energy. Longer wavelength, same phenomenon, different scale. Now, there is one final piece to this: how light interacts with matter. Because even though photons have no mass, they can still affect atoms. When a photon hits an atom, it can transfer its energy. This can cause electrons to move or jump between energy levels. This is how solar panels work. This is how cameras detect light. And this is how your eyes are able to see. At the back of your eye, there are cells that react when photons hit them. Those cells convert light into electrical signals. And those signals are sent to your brain, where they are interpreted as images. So what you experience as sight is your brain decoding patterns of energy, photons, carrying information from the world around you, and sometimes from across the universe, from distant stars, from galaxies, from light that has been traveling for millions or even billions of years. And yet, those photons still have no mass, no substance, just energy and motion, which brings us back to the deeper question. If something can exist without mass, if it can carry energy, information, and influence the physical world without being made of matter, then what does that say about reality? Because light is not just something we see. It is something that reveals how the universe actually works, not as a collection of solid things, but as interactions, fields, and patterns of energy. And once you start to see it that way, the idea of what is real begins to change.